Hello everyone. So in this video, we are going to continue with our C language series, and in today's video, we are going to solve a very important question which was asked in previous year examination of MAKAUT of I think semester 2. So let's continue with the question. Okay, so uh, let's solve the question. So the question is very important and a common one, but many students find it difficult sometimes as a beginner. So I have decided to uh, teach you about the solution of this question in part by part, but I will try to like complete the solution of this question in a single video. But let's see, the concept is important to understand. So the question is, write a C program to check if a given number is an Armstrong number or not. It was asked in MAKAUT 2019 examination. So what is the explanation? An Armstrong number, also known as a narcissist number, uh, is a number. Just remember this narcissist thing, maybe in your practical examination in your laboratory, or maybe in future semester exam, this name Armstrong can be changed to this, and it they can ask it to make this question actually tricky, they can do this. So now is a number, okay, Armstrong number is actually a number that is equal to the sum of its own digits, each raised to the power of the number of digit. Just focus on that line. At first, number of digit. Okay. So what it is telling, that Armstrong number is a number. Let's say 153 is a number, Armstrong number actually. So in that case, here you can see the LHS. So in LHS, you can see at first, before LHS, what is the number of digits in that number? 1, 2, 3. So three digits are in 153, means 153, this number. There are three digits. So we have to raise each digit to the power of number of digit. Here as you can see, each digit mean 3, 5 and 1. So we have raised 3 to the power 3, 5 to the power 3, and 3 to the power and 1 to the power 3. Why 3? Because 3 is the number of digit and 1, 5, 3, these are the digits, and we are adding them. So this total thing, if this total thing, whatever the result, is equivalent to that number, okay, from where we are doing this calculation, if it's equivalent or equal to that number, then that number is called Armstrong number. Okay, so that is the thing. I hope you have understood this thing. So we have to break down the steps. At first we have to learn about these things, okay, as a beginner, that how we can get the number of digits from a number. Okay, if we have a number, so how we can extract the number of digit from them. And another one is how we can like extract digits itself from a number. At first we have to extract the number of digits, because as you can see here, it is needed. As you can see in this case, in example, the number of digit is 3. So this 3 will come from this function, okay, which we will make. And another one, this separate digits 3, 5 and 1, this will come from another function, or some operations will occur there, that we will extract each digit, perform this thing 3 to the power something, and add this to the recent sum. Means let's say initial sum is 0, and in some step, in first step, we are doing this and adding this to that 0. Okay, so the sum will become that, means 3 to the power 3, means 3 3 is a 9, and 3 9 is a whatever. Okay, so like 27. So like in that way, in the next iteration, 5 to the power 3, it will be added to the previous one, means 27. Here you can see it's performing like that. After that, last extracted digit is 1, so it will be added to the previous sum, means the sum of previous two things. So that will be the approach. But let's go and find out the number of digit at first. Let's see what will be our approach. Let me open the browser. So let me open Chrome. Let me open Excel draw to explain the thing. Okay, here let's extract number of digit from a number. Okay, at first I am going to open online C compiler. I will be writing the code and explaining it. I will explain it simultaneously. Okay, so at first let's say we have this main function, and what we are going to do, we are going to make another function. If you have not studied about function is for now, uh, take it like a machine inside which we are passing something and it's returning something to us. So now in our case the return value will be definitely integer, because we will return the number of digit in that number. Now let's name the function as number of digits. So nod, inside it we are going to pass that number. So I am writing the variable name as num, and inside it we are going to do some operation and return. Okay, at first like there will be a variable called number of digit. So let's take it as n, where we are storing number of digits. Okay, and finally after some operation, here will be operations for calculation of total number of digits. Okay, sorry for the spelling mistake, digits. And finally we will return the value of n from this function. In that step, which is written in the fifth line, for now just the statement, now it's on sixth line. Here we will be updating the value of n. Initially let's set the number of digit as 0. Okay, now I will write some code here to calculate the thing, and then I will be explaining it. Okay, so let me write it. So we will use some while loop here till number is not equals to 0. Run the loop till uh, number is not equals to 0. Run the loop. Once it becomes 0, means number is 0, then we cannot extract or there is no digit left, so we will simply return the value. So logic is working like that. Now what we will do, at first, before that, like be, we will not directly apply or directly uh, like perform the operation in this variable. We'll simply create another variable, let's say temporary, because we are going to update the value of that variable, means update the value of number in our step. So inside this temp variable, now we have the same value as num, correct? Now we can use temp as the number. ঠিক আছে, let's say we have passed 153 here inside this function from this main function. Now we are storing this 153 inside another variable on which we are going to perform the updation things. Okay, so let's see the steps. Each time we will at, at first divide it by 10. Okay, and it will return the quotient, and we will store that quotient inside temp itself, means we are updating the value of the number by its quotient. Remember this line, we are going to update the value of number by its quotient each time it enters the loop. And after that we will just simply, as it enters the loop, means there might be or there should be at least one digit left, so that's why we are increasing the value of n, which is representing the number of digit. Okay, now let's understand this part, how it's working actually. Temp equals to temp divided by 10, correct? So let me write it here. Temp equals to temp divided by 10. Okay, let's take an example. Let's take 153. So let's take 153. Okay, now let's first time for the first loop execution, the number enters the while loop, the number enters the while loop, it's checking 153 not equals to 0. Yes, it's true. So now go inside the loop and execute everything. The first it will execute this thing, and at the very first it will execute that and then store it inside it. So we have to at first perform this operation. Temp, what is the value of temp initially? Sorry, here it will be temp because we are checking the value of temp. If temp is temp number actually, so we are representing temp as the real number which we have passed. So till temp, the value of temp becomes 0 means there are no digit left, we are executing the loop. And let's say in very fast what will occur, we are dividing temp by 10. Okay, and we know this slash operator in C language returns, after performing, returns the quotient. What does it mean by quotient? So actually we are dividing for first time 153 by 10, correct? So let's write simply 10. So what will be there? 15. Okay, 10 15s are 150, correct? 150. And what will be the remainder? This. Okay, now just focus here that this value we are going to take, because performing this operation is going to return to temp, or going to actually return, which will be assigned, equals to means assigned to the value of temp. Whatever value is present now, it will be updated to this operations value, return value, and it will return the value 15 for the first step. Okay, let's not focus on this for now. We will be focusing on it whenever we will be extracting the digits, because as you can see 3 is extracted from here and 3 is actually the digit. But let's not focus on that for now. For now let's just focus on extracting the number of digits. So first, so the value of temp in next step will be updated to 15 from 153. And now there was a step n plus plus, means n will be increased to 1, means one digit is there. So now current value of n, if I write here, current value of n is 1 after the first step. Okay, now in second step, as I have mentioned, value of temp is now what? Value of temp is now uh, 15. So in second step, whenever it passing inside the loop, okay, let's say here you can see these steps are executed and it will re-enter this while loop. And what is the value of temp now? The value of temp is 15. So 15 is not equals to 0. Yes, it's true. So re-execute this thing. This time the value of 10 is 15. So 15 divided by 10. Let's do it. So here there will be only 15, and we have to divide it, or we have to perform this slash operator. Okay, and we have to divide it by 10. So 10 ones are 10. Okay, whatever, like I'm not writing it properly, and remainder will be 5. Okay, it means for now the updated value, or the value which will be returned by the operation 15 slash 10. Okay, as you can see here, temp slash 10 means actually the value of temp is what for now? 15. So 15 slash 10 will return the value to the temp, or store the value to the temp, or update the value of the temp to what? 3, because this slash operator always returns this quotient. Okay, so now this line or executed successfully second time, and it will also be executed as default in the second time also. And the value previously was 1, now the value will be increased to 2. So now we can just simply erase this thing, and in the second time the value will be 2. Okay, now what is the value of temp for now? Okay, So now the value of temp is this one, means 1. Okay, means 1 for now. Now one will re-go to the loop, and it will recheck here. That's 1 is not equals to 0. Yes, definitely 1 is not equals to 0. That's why inner code will re-executed for the third time. And in this time 1 divided by 10, because the value, updated value of temp is 1. So let's execute it, and for sure in this time it will become 0. Okay, so 1 and here is 10. If we try to perform the slash operator here, 1/10, so 10 zeros are 10 zeros are 0, because we cannot divide 1 by 10, so remainder will remain this. This time this quotient value will be stored inside this temp variable for the third time. Okay, inside this temp variable. Now temp variable's value is 0, but as we have entered the loop and executed this and stored 0 inside this temp, after that the next line also will be executed. And what was the previous value of n? It was 2. Now as a mandatory part, whenever we are as a mandatory part, this n will be increased and it will become 3, as it's a part of inner code. So definitely whenever we will enter this block, this line will be executed. So final value of n is now what? Is now 3. Okay, and in this time what is the updated value of temp? As you can see, the updated value of 10 is quotient, means 0. Okay, so now it will re-go or try to re-enter the loop, and here the condition becomes false. Why? Because 0 is not equals to 0. No, 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 it's a wrong condition, means it's wrong. It will definitely return a false inside that. So definitely it cannot enter the loop anymore, and it will execute it will go out of this loop and return the value, current value of n, which is actually 3 as of last update. And now if you check, we were perform what was the initial number where we were performing? It was 153. What is the number of digit here? 1, 2 and 3. So 3 digits are there. And what is our result, or what our function is returning? Our function is returning the value of n, and the value of n is surprisingly also 3. So it's correctly returning the value of number of digit in a particular number. Similarly you can try run with another number. Okay, now try with let's complete this program and try to pass different type of numbers, and let's try to extract the number of digits from them. Okay, now for now, let's say there is a number variable here. We will take the input of number and return the number of digit in that number to the user. So enter the number. Okay, we'll at first instruct the user. uh, After that scanf, and inside it, as it's an integer type of value, num is an integer type of value, so we are going to store inside this address of num, and the format specifier is %d. Now uh, we have all successfully taken the number input from the user. Now we will call this nod function, or we can directly, like, at first we can make a variable called result. Okay, result, and inside it we can call this nod function. Inside which we are going to pass that number which we have taken from the user. Okay, now after that let's print the result. So as it's also returning integer type of value, as you can see, number of digit is an integer type of value. So %d and comma and address of sorry, as we are printing, so we need not to write address, because we are not going to store, we are just going to print the value. So directly we can write result. Okay, so result, whatever value will be stored in inside the result, it will be printed. So that is the thing. Now let's add a slash in for better visibility or better structure. Okay, now let's run here. Let's enter 153. Okay, let's enter 153, enter. So it's oh sorry, it's I think 53. So like let's rerun it, and 153, enter, and it in this time it's returning 3, correct? So now let's rerun it, and enter a number of, let's say, 4 digit. Okay, let's say 5 digit, 1 2 3 4 5. So it should return 5, the number of digit is 5. Oh sorry, we have actually rerun. We had to actually enter. So let's re-enter a 5 digit number, enter. Yeah, it's successfully returning the number of digit, correct? So that is the thing. Now this is a single part or a one part of uh, the thing or the question which we are going to solve. Actually we are not going to use this type of things, but the function which is returning that digit, we are going to use this thing, correct? Okay, so like that is the thing. Now let me see how much long is this. Okay, 21 minutes, no problem. Let's I think we should go to the next part. Okay. Okay, so you can take some break and you can return back, but I have taken some break to explain you the next part, and now I am ready to explain it. So let's continue with this video. Now we have successfully done this part. We have to at first extract the number of digits. Okay, as we have to raise each digit to the power of number of digit. So we have already, or we are getting already the number of digit from that function. Okay, NOD function. Now we have to extract each digit, raise them to the power 3, and add them to the previous sum. How I will do it, let's see. Okay, let's, like previous one, let's at first write the code snippet, write the function, and then we are going to or I am going to explain it. Okay, so just for now, keep it aside, or like keep it aside. Now I am going to write another function here, which I am going to call uh, I am going to call operation, or let's say sum operation. Okay, sum operation, where we are going to perform that, we are going to raise each digit. Okay, we can name it like digit extraction, so I am writing it in short, digit extraction and sum operation, so DEASO. Okay, now inside it we are going to pass that number, int number. Okay, and what we are going to do at first, let's see, and then I am going to explain it to you line by line. What will be the purpose of this function? It will do the sum, okay, of the digit which are raised to the power of number of digit, and it is going to return that sum. Okay, and in another function. Okay, for now that is the thing. Okay, now it's going to return that sum. What I mean to this, like it's going to perform this operation, like this part, and going to return the final value. In our case the final value is 153, so it will going to, or it's going to return that 153. Okay, so let's do this thing. Okay, now we have this number. So which things we have to do? At first we have to get the number of digit from that number. Okay, so for now we are going to pass this number. Don't don't watch here, don't see this part. Let's say this is the function where we need the number of digit. Okay, so let's make a variable. Let's say int number of digit, or let's say power. Okay, so I'm power let's say variable, and inside it I am going to call this function number of digit nod, and inside it I am going to pass that number uh, which I have, means this number. Okay, I'm going to pass this and it's going to return the number of digit, and we are going to store it inside the power, because the number of digit is finally going to be the power of each digit. Now what we have to do, we have to extract each digit. Okay, each digit. Now before writing that, I want to make another variable called sum and assign it to 0. Initially the sum will be 0. So the functionality which we are going to write here, we have to extract each digit, comma, raise raise them to the power. Okay, to the power means to the power of this value. Okay, to the power means this value, then add to the sum uh, using a loop. Okay, add to the sum, and we are going to do it for each digit in that number. Okay, so we are going to perform this thing here, and finally we are going to return what? We are going to return that sum. Okay, now let's write that functionality. So at first what we have to do, we have to extract each digit. So what will be the function of digit extraction? If you can see here, whenever we were running this thing, we are getting actually slash actually gives us what? Slash gives us the value of quotient. And if I write another line here, okay, let's say I'm writing digit equals to whatever the value of 10 percentage 10. How it will work? Simple, simple. Just focus here. Every time we are going to run that while loop. Now, why this will update the number, okay, to that quotient value, to that quotient value. And how we can get this, because these are the digit, right? This is the 3 which is actually a digit of that number, 5 is also digit of the number, and finally 1 is also digit of that number. So in 3 layers, or 3 times, or 3 executions, we are getting different digits of that number. So simply instead of slash, we are going to perform this percentage operator, because whenever we are performing this percentage operator, it's going to return us the remainder instead of the quotient. Slash operator return us the quotient, but percentage operator is going to return us the remainder. So it will return 3 in the first turn, then 5 in the second turn, and then 1 in the third turn. So whenever it will return 3 in the first turn, we will store it inside this digit. Now we will we will raise this digit to the power, to the power of, let's say, if the number is 153, then the 3. Okay, so let me write the code line, and we are at first we are going to raise to the power of that, calculate and store it inside the sum, or add it inside the sum. So let me write the code snippet, then it will be more clear. Okay, now let me go to the coding part. Here you can see this is the, sorry, uh, where is this? Okay, actually this is, here we are going to use the pow function. Okay, which is inside the math.h library. Okay, now what we are going to do, at first let me write the code. At first let's say we are going to write similar while loop, because we have to change the number. So here also I am going to make a temporary variable. Let me copy from the previous one and store the number inside it, so it will be better. So let me make it, and yeah, that's the thing. Now inside temp, now the value of num is there inside temp, so we can get the same result if we perform the operation inside temp. So till temp means our number not equals to 0, we are going to execute this loop multiple times. Okay, now at first what we are going to do, we are going to uh, like we have the we have the power inside us, we need the digit from here. Okay, first time the number will come 153, so at first we are going to store the digit. So if I write, or if I declare a separate variable digit, inside it we are going to perform this temp. Now percentage 10, which is going to return us the remainder for the first time, which is 3. Okay, now let's close it, and sum was a variable which is initially 0, so we are going to update it by previous sum plus, means whatever sum was there, plus we are going to use the pow function, because pow function is going to uh, at first it's going to take the number, means the digit. Okay, digit, and it's going to raise it to the power, what, to the power variable, means from this power variable the actual power, which is in our case 3, is coming. So it's like, visually it's like digit to the power this power variable. Okay, so that is the thing. So each time we are going to do that thing and going to add in the previous sum. If I show you this thing here in our example, so this thing, like first time 3 to the power that power, and power will come as 3 if the number is 153 definitely. So it's going to add it to the 0. Next time it will going to, it's going to extract this 5 and raise to it to the same power and add it to the previous sum, and previous sum was what, 0 plus this 3 to the power 3, so it's going to add it to the this, and finally it's going to add it to the previous sum, what is this. So final result will become this as sum. So in that way we are checking. So how we can write it, now it's going to do this. Now we have to update the digit also, right? Because if we do not update the digit, then we cannot, or we are not going to able to get this 15 value in the next turn of the loop. Okay, because as this, as we are like storing this value of quotient as the new value of the number, updated value of the number, so we need to perform this temp/10 now after storing these values. So what I'm going to do, inside temp I'm going to update its value to temp/10. Okay, it's going to store, update the value of this, and it's going to check and recheck and update digit, and going to like do the, going to execute these things, execute these parts. Okay, now after that finally some, there will be some like some will be there. Okay, whatever it will be, and it's going to return as an integer the value of sum. Now it's the number of digit, so simply uh, we can, now we do not need the number of digit. Actually we are uh, actually inside this main function we do not need this number of digit. Okay, we just have to show if the number is Armstrong or not. So now finally what we are going to do, we are going to create another function for checking if it's a Armstrong number or not. Okay, so let's write a function check, check Armstrong. In shortcut I have written arm, and inside it I am going to pass this number. Okay, and what I am going to do, at what will be the step. So at first I am going to store it inside inside a variable. Okay, inside the variable, next time I am going to extract the operational sum. Means operation means whatever operations we have performed, whatever conditions we have make for like which is actually needed for the Armstrong number. So like as of the concept of the Armstrong number, so we'll like extract this, and also operational sum, I'm going to extract this operational sum and store it inside another variable. Okay, inside another variable. Okay, that's cool. Variable. Finally, what I am going to do, I am going to check if both are both are same or not. And if both are same, it means it's a Armstrong number. If both are not same, then it means it's not a Armstrong number. So we are going to print that thing. Okay, so that is the functionality of that function. So in this step, first step, we are going to do what we are going to do. I'm going to store it inside a variable. So let's make a variable int real number, because it's the actual number. Let's say make the variable name as actual actual number. Okay, actual uh, number or number, and inside it I am going to store the value of num. After that, what I am going to do, I am going to extract the operational sum. So what do we have to do at first? uh, Op sum. So I have mentioned or declared a variable, and inside it I'm going to call this function. Okay, call this function which is going to return me the sum. Okay, we don't need to write this thing, because it's actually this thing means NOT function. We don't need the reference of NOT function. We need the reference of NOT function inside this function itself, and we are actually getting the final result from this function. So we can directly call this function, and from this we can get the operational sum. Okay, and inside it what we are going to pass, we are going to pass that actual number, means that like actual number. Okay, let's pass this inside it. Okay, now what I am going to do, I am going to write a line, if that num is equals to okay, of sum, that num is equals to of sum. I am going to printf that it's a Armstrong number. Okay, it's a Armstrong number. Else, what I am going to do? Else, I am going to print it. It's not a Armstrong number. Okay, it's not a Armstrong number. So this is the finish of our code. Now let's run it. Let's. Okay. I think I think we need another header file called hash include math.each. Okay, and let me check the like this main function. Okay, actually we have not called that check. Okay, check arm function inside the main function, from where actually the execution pass, and from here we are going to pass the actual number. Now let's execute it. Else statement. Okay, okay, fine. Oh, sorry. Here it should not be like that. Here will be a bracket, and we can give a bracket here. So these are some small problems. Okay, let's check for 153. As we already know, 153 is a Armstrong number, so it should return it's a Armstrong number. Yeah, it's returning it's a Armstrong number. Now check for another like another normal number 78, let's say. Okay, it's not a Armstrong number. Let's search on Google for Armstrong numbers example and let's check one by one. Armstrong number example. Okay, example, these are the Armstrong number. 370 is also they are telling that it's a Armstrong number. So let's check for 370. I think it was 370. Yes, so it should give it's a Armstrong number 370. Let's run it. Oh, sorry, we have to actually enter. Okay, not run. So 370, let's enter. It's a Armstrong number. Fine, it's working fine. Let's check for 370, sorry, 401, sorry, 407. 407 is also Armstrong number. So let's run the program. 4 what 407. So let's write 407 and enter. It's a uh, oh, sorry, 707 I have written, so I should write 407 instead. 407. So let's enter, and it's a Armstrong number, so it's working fine. Correct, it's working fine. So that was the question. I hope you have understood in depth about the whole thing. I will definitely be attaching this code inside my description as well as in the comment section. Check both of them. And yeah, that is the thing. If you have understood this program very easily in easiest way, don't forget to like this video. It will definitely give me motivation to make more videos like that. As well as sorry, as well as like in next videos. Okay, before that I want to tell you that those who have completed this video till till the end, they will be solve so many questions based on this concept where the number of digit and digit extraction is needed. In so many questions in your university exam, you can see these things are actually needed. So you will be definitely able to tackle those things very easily if you understood this video. That's why I have explained it slowly so that there can be or there will be no problem. So that is the thing. Thank you for watching this video till the end. Please give a like if you have watched this video till the end and understood, and don't forget to subscribe the channel. It will definitely give me motivation for making next videos more better. So thank you for watching this video. There is a HW for you. Write a program for from where it's a very easy, but do it from where you have to output the sum of all the digit of this of that number. Okay, you have to take user input. Okay, so thank you for watching this video and goodbye. Let's continue from the next video.